Okay, these video solutions for assignment 37 and question N7. Okay, so in N7 part A, you're asked to write 5 cos theta minus 12 sine theta in the form r cos theta plus alpha. So how I'm going to do that, I'm going to lay this out in the following way. I'm going to say r cos theta plus alpha is equal to 5 cos theta minus 12 sine theta. Okay, and then beneath this here, I'm just going to write this again. Now what I'm going to do on the right hand side now though is I'm going to think about how r cos theta plus alpha could be written. Basically I'm going to use the compound angle formulae for cos. So in doing that, this can be written as r cos theta cos alpha minus r sine theta sine alpha. Now I just have to compare these things basically. So I can see here cos theta and cos theta. So if these things are the same, this term here must be like my cos theta term, which means r cos alpha is going to have to be equal to 5. I'm following the same logic over here. I've got sine theta here, so this must effectively be my sine theta term. I know that r sine alpha must be equal to 12. Okay, I now need to figure out r and alpha. I know I can do this because I've got 2 equations, 2 unknowns, so it's definitely possible. The easiest way to do it is r squared is going to be equal to 5 squared plus 12 squared. If you don't know why that is, just ask your lecturer, because there's a nice straightforward way to show this, alright, but you know, it's one that once you get to this point you can just pretty much state. So r is equal to the square root of that, which is 13. So r is 13. Just moving down a bit. Okay, now I want to find alpha. How can I do that? Well, if I write down r sine alpha over r cos alpha is equal to 12 over 5. Why does that help me? Well, it helps me because those r's are going to cancel, and sine alpha over cos alpha is tan alpha. So tan alpha is equal to 12 over 5. And solve that to one decimal place as asked, and we're going to get 67.4 degrees. So how can we write 5 cos theta minus 12 sine theta in that form? Well, it can be written as 13 cos theta plus 67.4. Alright, so there we go. We've now rewritten what we started with, which was 5 cos theta minus 12 sine theta in this form here, which is 13 cos theta plus 67.4. Okay, going on. Okay, so in part B, I'm just trying to find the question here, they're written down somewhere. In part B, we are asked to solve 5 cos theta minus 12 sine theta is equal to 4. Okay. In an exam, they'd probably use the word hence here. They would probably say hence solve this, all right, which would be a huge clue that you're going to use what you've just done in part A to help solve this. So that left-hand side from part A, I know can be rewritten as 5 cos theta plus 67.4 is equal to 4. And this is much simpler to solve in this form here, okay? Divide by 13, so cos theta plus 67.4 is equal to 4 over 13. Whoops, I wanted to scroll then, not do that line. Just ignore that line if you will. Okay, going from here, next, so arc cos, we get theta plus 67.4. So theta plus 67.4 is equal to 72.1. Now do not at this point subtract 67.4, or else you're going to get, basically that will be the only solution that gets correct. The other ones will be incorrect. All right, what I'm going to do is I'm now going to find my other solutions, all right, for theta plus 67.4, and then I'm going to subtract 67.4 for them. I'm actually going to adjust basically my domain here, because for theta I want the answers, I believe, between 0 and 360. So my answers for theta plus 67.4, I want to be in the range 67.4 up to 360 plus 67.4 is 427.4. So basically I'm going to find all my answers in this range here, and then I'm going to subtract 67.4 off each one. So doing this, 72.1 is basically in that range straight away, so that's one solution. Another solution is going to be, I'm just going to write this again down here. So 72.1 is a solution. Another solution is going to be at 360 minus that. You can get these from drawing the cosine graph, all right, to make sure you're in the, you're finding the correct ones. Is going to be 287.9. All right, and the next one after that would be 360 plus 72.1, which is actually going to be outside of 427. So I'm not going to use that one. So there are my two solutions for theta plus 67.4. So now subtracting 67.4 off each one, we get theta is equal to 4.7 degrees. And subtract 67.4 off 287.9, and we get 220.5 degrees. So they're both my solutions there to finish. Okay, moving down a bit. Now on to part C. In part C, we are asked what is the maximum and minimum value of, I haven't actually got the question here in front of me. It may have said the same thing again. I'm just going to assume it did. So part C, 5 cos theta minus 12 sine theta. Okay, what is the maximum and minimum value of this function? Well, this can be rewritten, as we know from our part A, as 13 cos theta plus 67.4. I actually, like I said, got the question. It may have actually just said straight away what is the minimum maximum value of this, but it's the it's the same thing, like I said. So if they said it was what's the minimum maximum value of 5 cos theta minus 12 sine theta, you're just going to rewrite it as this anyway, because this is much easier to deal with. This is why this is a great technique using the R method. Okay. Now, what's the maximum value of this? Well, at the maximum, just think what happens to the cosine graph. What happens to the cosine graph of theta plus 67.4? Well, basically, it's just like this. It's just basically bobbing between 1 and negative 1. Okay? So when does the maximum occur? The maximum occurs when cos theta plus 67.4 is equal to 1. And what will happen when it is equal to 1? Well, the maximum will be 13. So the maximum is 13, and it happens when cos of theta plus 67.4 is equal to 1. So to find the value of theta when it happens, I need to solve this. So theta plus 67.4 is equal to 0. Your calculator will give you 0, but I notice straight away, look, if I've got 0 and I take 67.4 off it, I've got negative 67.4, which isn't in the range I wanted. I wanted between 0 and 360. Another solution, though, to this would be at 360, which will actually give me the solution I require in the range I want. So basically, theta is going to be equal to 360 minus 67.4. So theta is equal to 292.5. degrees. Okay, so the maximum is 13, and when does it occur? It occurs at, when theta is 292.6. Okay, last bit. It said max and min. So I've got 13 cos theta plus 67.4. Okay, what is the minimum and when does it occur? Well, again, cos of theta plus 67.4, what happens to that? Well, it's bobbing along, remember, between 1 and minus 1. Okay, so when is the minimum going to occur? It's going to occur down here when I've got cos of theta plus 67.4 is equal to negative 1. When it is equal to negative 1, what is that minimum going to be? Well, that minimum is going to be 13, obviously, times negative 1. It's going to be negative 13. All right, it's just something we can state. So the minimum is going to be at negative 13. And when does it occur? It occurs when cos theta plus 67.4 is equal to negative 1. So find the value of theta when it happens. Solving that, I get 180. Okay, and I can actually see this is going to be the only solution I require, and it's going to be in the range I want. So subtract 67.4 from 180, so 180 minus 67.4, and we get theta is equal to 112.6. Okay, so the minimum is negative 13, and when does it occur? It occurs when theta is 112.6. Okay, that's the video solution for N7 on assignment 37.